Okay, everybody, welcome to the Thursday, November 21st, 2019 session in our series about edge computing. And I'm Richard Dasher. I direct the U.S. Asia Technology Management Center at Stanford. We're very happy to produce this series, and we want to say thanks to the member companies and our industry affiliates program for providing us support that let us keep going. Thanks to our member companies, we've got some refreshments out back at the end of the session. We hope you'll stay around, meet our speakers, meet each other after the end of the formal part of the program. So today we have another use case for edge computing, right? We had talked about some enabling technologies in several of the sessions so far. Last week, remember, we had LeapMind from Tokyo by live video conference, and they have a software stack to enable edge computing in a wide variety of applications. We had also looked at autonomous vehicles, and we had also looked at medical data, where it's a totally different motivation for using edge computing as opposed to cloud computing. So today, we're going to talk about augmented reality and virtual reality. I'm delighted that we've got exactly the right people for this presentation. So our first speaker is going to be Dijam Panigrahi, who is the co-founder and COO of Grid Raster. And Dijam has a rich experience of over 16 years in building and deploying and taking to market various mobile and network-based products. Before founding Grid Raster, he worked at Texas Instruments, Freescale Semiconductor, and HCL. He's really leading the business development, product marketing, and partnership at Grid Raster, and he'll tell us more about what Grid Raster is doing.
Sure.
Next, or closest to me, is Dhnanjay Lal. DJ is Senior Director in the Emerging Technologies team for Charter Communications. As such, he's providing strategic leadership and direction on service delivery innovation over the network for new use cases such as cloud gaming, AR, and VR. He has led the product team at Time Warner Cable Smart Home Service, and he's had various engineering roles at Emerson, Eaton, and Bosch before joining the cable broadband industry. So as you see, this covers a couple of pieces that we really needed to have covered in the series this fall. Not only this use case, but also from the standpoint of the telecom company, right? The communication side, how we're going to get this to the network. So without further ado, let me turn over the microphone to Dijam and ask you to give us your comments.
Thank you.
Floor is yours. And we can just go sit down.
Hello.
DJ, wherever you want. Up here or over here?
Hello.
Let's watch this presentation. Yeah, let's watch.
Yeah, just before I start, how many of you have tried the augmented reality and virtual reality? Just a show of hands. Okay. And how many of you wish that the device that you're trying is something as easy as like a glass? You just pick it up and where you actually see the immersiveness that you see in the bulky ones right now. So I think there's a long way before we kind of do that, and there's a big role that the cloud and in specifically the edge computing would be playing to make that reality happen. So a little bit about me, and the idea, the genesis of the company Grid Raster. How did we kind of come to form this? I've been working in the space of network and mobile for the last 15 years. Have been through the first dual-core processors to some of the defining technologies in 3G and 4G. And not only from a deep engineering aspects point of view, but over a time period, I've moved into product and have taken some of these products into the market across different geographies. During actually the work in our previous role, we started getting the requirements for augmented reality and virtual reality almost 5 and 6 years back when we were talking about enabling this whole 5G network. And at that time, like also, what we see is there are other technologies which was kind of evolving, which will ultimately kind of converge to kind of make certain things happen the way the things are shaping up today. One of the things was the GPUs. The advancement in the GPUs was making it possible to do the kind of compute or the processing that you specifically required for augmented reality and virtual reality. Also, with the advent of the 4G LTE, then there is the outlook towards the 5G. The data pipes were beginning to become thicker and thicker. But the problem, what we kind of realized was the attempt to have these experiences on a mobile device, which is in a form factor, which is confining in the sense that you can't put an active coolant over there. You can only have so much of the GPU that you can cram into those kind of devices. Was a big deterrent when it came to proliferating those experiences across mainstream use cases or enabling much sleeker designs which people can kind of wear. And from the work that we were doing, we got some insights around like how can we make use of the remote compute, which in this case, which we started terming as the edge compute, that you are able to offload the compute-intensive task onto the remote server and be able to still deliver very, very high-end experiences on an untethered mobile device. And with those insights, actually, we started the company Grid Raster, and we have come a long way there. But before I delve into what exactly we do at Grid Raster, I want to kind of touch upon a little bit around on edge computing, because this edge computing has become a loaded term in the sense like people conveniently use the term based on like what suits them. Not that anybody is wrong there, but just that I just want to set the context in that when I'm talking of edge computing, I'm talking in a certain context. But irrespective of whoever you ask, one thing that is common, like everybody would agree that the fact that you're moving the compute closer to the user or the place where the data is kind of getting generated is what is termed as edge computing. And that compute, you're placing it, if you go to a device manufacturer, they would say, okay, it's all about the edge is the device edge, because they're trying to put on the sensors, you're trying to put some compute so that you can do a lot of those processing analytics on the device itself. If you go to the network players, they would talk about the network edge, because on the base station, they're putting the compute, and they're going to term that as their edge. But when we talk, in our context, when we talk of edge computing, it's the first hop from the end device. So it's the first hop on which we'll be offloading the compute from the device is what we, as a company, and in general, the community kind of believes. Why is this, like, what is the need of this whole edge computing? Like, the cloud was working fine. What happened? So there was fundamentally the two shifts that was kind of happening. One, it's the data. And it's not the data just the way we know it. It's about the first time in the history that we started capturing the real world data in such a massive amount that it was just impossible to put that onto the network. So, and take it all the way to the cloud and start processing it. So, for example, I just took if you talk of a self-driving car, a self-driving car in a day generates almost like 4 TB of data. Are you going to get it onto the cloud? That's not going to happen. It's not going to be supported. If you actually go into the smart factory, where the factories are designed on the Industry 4.0, you are looking at 3 petabytes of data in a smart factory kind of scenario. That's like humongous. That's humongous. And the other thing is that you are trying to, the second aspect which was there, not only that you are generating this massive amount of data, but the actions or the value that you're trying to drive from this data has to be done real time. Otherwise, the value kind of goes. Like in an autonomous vehicle, if I'm going to, using my computer vision, I want to detect there's a stop sign, the car has to stop, the decision has to be taken there. You can't just put it there back to the cloud and take a decision. That doesn't work. So in case of like augmented reality and virtual reality, you're talking about like you're moving your head and the whole scene, what being rendered within the sub 20 millisecond. If you're trying to do that, you just can't put it to the centralized cloud and try to process and render and just get that done. That's not going to happen. The need, the massive amount of data that's been kind of put into the network by this, all the sensors, the IoT, even all the cameras, that's something which was one of the reasons that kind of drove this change towards the edge computing. And second thing, the requirement to kind of process this in real time, where you almost have minimal latency, like ultra low latency is something which kind of drove this whole change or the movement towards the edge computing. So what are you going to see now? Because all this whole edge computing, you're going to see the network and the whole compute infrastructure is going to evolve in a certain way. And what you're going to see is going to be a hierarchy of compute. So you'll have the compute. So all the compute nodes will have its relevance depending on a use case, depending on the task that you've been done, depending on a certain use case. But what you're going to see is a hierarchy of compute. The cloud is going to still play a major role, but you're going to see the compute that is on the device, the compute that is on the base station, the compute that is on the edge data centers, which is being built out, is going to have a role. And each of them are going to be used in a very specific way depending on the different use cases. And it will be a case that you're trying to see whether you are trying to adjust to the latency or whether you're trying to address the cost. It's going to be a trade-off between both of that. And based on those use cases, you're trying to now orchestrate, you're trying to build efficiency in the network, and then kind of deliver different experiences. So I think some of the benefits are pretty self-evident. You know, you're moving the compute closer to the user, so you're getting a much, much faster response. You're avoiding the data overhaul on the data hauling over the core network, which doesn't do the network congestion, and that is directly related to the overall cost reduction because the transport cost of all this humongous of data is going to be like huge. Secondly, the fourth thing is there is going to be a improvement of the data security. Like just take the example of a hospital. Like there are certain data you never want to kind of put it out onto the cloud. Like there are patient data that could be kind of just be processed, what needs to be processed at the edge, right at the hospital, but there are certain inferences or certain learnings that can actually go to the cloud. So there's a whole structure that's going to be kind of built out, which helps you kind of having a better data security and compliance with the regulations that are in place. And of course, the better quality of service. You're going to get much more predictable latency because you're looking at minimizing the number of hops that will be required to do things in the network. So that's going to be a huge asset. Coming to GridRaster, so what is that we are doing? How this whole edge computing and everything is trying to kind of help AR, VR move forward. Okay, so at GridRaster, what we are building is a cloud platform which will be deeply kind of be using this whole concept on the benefits of the edge computing and the 3D vision-based AI to enable you to build very highly scalable platform. So where you can run, any number of use cases across different locations. You can scale number of users. You can scale your entire virtual world. So we are building that aspect. And I'm somebody like who completely sold on this. We completely believe that the AR, VR is going to completely transform the way we do our work, how we live, the way we interact with the world, how do we entertain ourselves, like how do we communicate. It's going to completely be changed, but there is a long way to go. So we have seen the evolution of mixed reality. I just wanted to touch upon like how things have kind of emerged and where we are and where we will be in maybe sooner than later. So at the beginning, you saw very rudimentary experiences, right? So you saw maybe a Pokemon Go where there's a very rudimentary experiences where you were kind of overlaying certain specific things on the real world. You have seen the I don't know if you've seen the IKEA app, which allows you to kind of get your furniture. You take your house and kind of drag your furniture and put it and kind of replace it, and so that you can plan your whole setting, like how you want to kind of design it. But whatever said and done, they were pretty rudimentary, and most of them was on the mobile. So it was kind of done just, but it was an excellent way where people kind of got introduced to that concepts. Today we have come like further than that. We can create some sort of telepresence where you could be ported to a different world and you feel that you are there. And also you will see that we are able to create certain kind of visualizations, right? Like in the industry, they're doing is the CAD models, which they were initially kind of working on the workstations. Now you are actually able to have those models right in front of you in full high fidelity and just walk around it as if they are like physically there in front of you. But whatever we have done till now, you still have, there's a clear demarcation between, okay, here is the virtual world and here is the real world. Okay, that demarcation is completely there. Okay, what we are moving towards is where you will completely, the distinction between the virtual and the real will kind of go away in a way. So the virtual world will be overlaid in such a way in the physical world that it will be almost be indistinguishable. Okay, and from a technical aspect, we're talking about reaching at like 16K resolution, then 120 frames per second. There are other things, and the ability to overlay them at absolute millimeter precision. So all those technical aspects we're kind of addressing. But this is not going to be possible. The kind of the technical requirements that's there to do that is not going to be possible without using the cloud. And we see that ultimately all devices will converge where cloud will also, the same device will provide you the AR experience, and possibly VR will be a mode within it where you switch to a VR mode and you have VR experiences. So while we believe that's going to happen, okay, but this only be able to be pervasive, which goes to everything and starts having mainstream, as I mentioned before, as long as those devices is mobile and untethered, okay? And but today, I mean, to cram in those kind of compute and battery requirements, like it's almost going to be like 100x compute, higher compute that will be required to reach there than what we have today on the device. So in order to do that, you basically have to fall back on where would that extra compute would come from, and that's where. So that's where Grid Raster kind of come in. So what essentially we do is we have been able to build a platform that would be able to offload all the compute intensive tasks, right? The heavy rendering, okay? The 3D world reconstruction, the 3D AI where you're doing a semantic analysis of the different objects that's there in the scene, and you're trying to find the relationship with each object with each other and also with the physical world. So all this compute intensive task we have been able to kind of offload to the cloud, which in this case we're talking of the edge cloud, and there are certain aspects even within the rendering that you can actually offload to the cloud, like the global lighting. Global lighting has a much higher latency budget. So even if it's like 200 millisecond away, the cloud is 200 millisecond away, you still be okay to kind of when the experience will be okay from a user point of view. So we have been able to kind of distribute this different compute tasks onto different nodes and bring them together in such a way that from a user point of view, they're looking at absolutely fully immersive experiences without the constraint of the device compute. So apart from the fact that we are able to distribute the compute and be able to do that, there are so many other technical challenges we need to address to make this experience possible. Like, how do you deliver this on a wireless network? Like, a wireless network known to be pretty finicky. How do you take care of that? How do you decide what tasks to be distributed where? It's all dynamically. Like, how are you going to do that? How do you schedule those tasks? So all those problems is what we're kind of addressing at GridRaster, and kind of working with some of the large companies in telecom and large enterprises in aerospace, automotive, to evolve the product, and we continue to do that. This is just from a little deeper, like architecture, in terms of what we are trying to do. As the core pieces that we are trying to do is on the rendering, the 3D AI, and the 3D world reconstruction. But having said that, like these are still these are the core technology. But in order for us to kind of put that together in such a way it's kind of usable, there is a lot that you need to do around it. The first thing is beyond the core tech, what we have been able to build as we kind of productize the whole technology is the ability that you can actually have different kind of devices. Like, people are going to have different devices, okay? You can't really control who uses what device. So with our architecture, what is going to happen is whether you want to use an Android, or you're like a HoloLens, or you're an Oculus Quest, you should be easily using it through pretty easy API integration. And same thing on the content side. So when we in the consumer domain, most of the content that you would see today is Unity-based. But if you go to the industry, you have different like CATIA models, you have Autodesk, you have PTC, Creo. So we are providing the APIs so that the onboarding of all these applications is going to be extremely easy when somebody comes onto our platform. And third thing, from a deployment standpoint, what you would see today, that many of these enterprises, just because of that whole data security pieces, they do not want to deploy that onto the public cloud. Okay, so cloud which is open to others. So for us, it was important that we provide both the deployment scenarios, that whether they want to deploy it on-prem or deploy it on the cloud, we kind of facilitate both of it. And the results that we have seen has been extremely good, okay? And on back of it, like for example, if you take a standalone Microsoft HoloLens device, which is considered to be the best in class right now when it comes to the AR glasses, the maximum polygon that you can actually run on those devices is 100K, okay? So if you have something which is kind of going to be bigger than that, all that you have to do, okay, you have to kind of optimize and decimate it. The right word is decimate, because you got to kind of remove that, okay? So, and that's a huge problem for a lot of companies, particularly in the enterprises, where there is a reason why the models are created with that fidelity, you know. But with using our platform, you can, with a single GPU, we can actually scale up to like 50 million poly. 15 million poly complexity of models can run using our architecture, using a single GPU. And if you have more, if you want to run 100 or 200 million poly, all that we got to do is kind of spawn few more GPUs to kind of enable those experiences. 60 frames per second is still kind of is the yardstick, because most of the displays that you'll see that has 60 frames per second. That's a device constraint that we have to work with. Motion to photon latency, you want to ensure it's a sub 20 millisecond motion to photon latency in terms of augmented reality and virtual reality. Like for people, the motion to photon. So the whole thing is about, if I take an action and I move my head, the scene that has to kind of move within the sub 20 millisecond. That's from my motion to the photon, the view has to be sub 20 millisecond. And today, from the network, even if your compute node is like sitting 40 milliseconds away, we can still bring down the perceptible delay, which is the motion to photon latency, to sub 20 milliseconds, because we're using a lot of that predictive algorithms, caching, and there's a whole bunch of techniques that we're using to kind of do this. 3D spatial mapping. Today, like the devices kind of map at 1 frame per second. Because we are not constrained from a compute standard, we can do it absolutely 60 frames per second, which allows us to have much more fine-grained, create the fine-grained meshes, which then we can actually use it for more precise rendering. So we can overlay the virtual objects on a physical world in a much, much precise way, almost to a millimeter precision than any of the current state-of-the-art devices could do it. Yeah, so this is all from a technology, performance, and point of view, like where is it being used? The question is like, okay, it's awesome that we are getting some technology in place, but where is it being used? Actually, for most people, the beachhead always had been gaming. Like when it came to VR, VR kind of was pretty much led by the whole gaming thing, okay? But when you come to AR, actually, it's primarily is being driven by the enterprise use cases. And the use case, it's no more, the use cases are no more in like experimental phases. They're actually getting deployed. Okay, when I talk about, so most of the use case is like the design and engineering, where let's take specifically for a car design. When you're doing a designing of the car, earlier you used to use the foam models or the clay models to kind of create those models, textures, and overlay, and all of that was kind of happening. And today that is being almost replaced by AR, where you can now you can create a physical foam model to start with, but all the iteration that whether I want to change the dashboard, I want to kind of overlay the different grille or the rear view mirror, so you can keep those iteration as quickly, almost like real time. You can do that, which that design which used to kind of take almost months to complete, now you can actually do that in days. On the operation and manufacturing side, so there is with the AR glasses, actually the level 1 employees are is outperforming level 3 employees. So there's a huge jump in the productivity or the efficiency with which they can do things. Training, like training has been an absolute success. All the employees who today join Walmart actually are mandated to go through the VR training today. Consumer experiences, like I think if you happen to get an opportunity to go with any of the Audi retail stores, they have those VR experiences there where you can actually customize your car the way and then just get into VR and just you see the car, what you need, and even in that VR environment, you take it on a drive to a mountain or a sea, depending on what kind of a person, what you fancy there. So today, like that's going to be the deployment where the automotive, aerospace, and industrial, which is kind of picking up in a big way. So that's why we are focusing, but we are keeping an eye on the consumer use cases. We believe most of the people are going to be introduced to VR and AR through work, and that will kind of help even propel the consumer adoption. There are certain future trends which will further kind of help in proliferation of the immersive medium. 5G is definitely one of the big pieces. I was just having a conversation just before we came here that today, okay, the compute part is taken care of. What about the bandwidth? Either 5G will unlock some of those problems. So you're going to have further lower latency, then better throughput. You're going to use the spectrum in a much, much better way. As I said, the enterprise use cases is going to kind of propel many of the adoption in the consumer AR/VR. And also there is we believe that there's a big scope for the peer-to-peer network, where like, just think of it, any device at your home you're creating your own virtual cloud. That's something that is going to happen, so that any device within your in your house is can you use the compute of any other device which is sitting idle? I mean, and those things are going to kind of also help in a big way the whole concept of the immersive thing using those compute which are sitting idle. So that's it from my side for now. I'm happy to kind of address any other questions which are there. And happy to chat after the end of the session.
Yeah, we'll do that after our other speaker speaks.
Thank you very much.
While you're standing here, before you sit down, though, as I'm changing slides, I want to ask you, is one of the reasons why AR and VR has not been deployed more because of kind of user fatigue? Or how do you see that as playing in?
No, you're true. Actually, there are multiple things which are there. Obviously, one of the thing is the price point. Many of them, from a device standpoint, the price point is also a big deterrent. And the fatigue part that you're talking about has a lot to do with the fidelity. Because see, the human eye, the feeling of nausea when you are actually wearing an AR or VR glass is a lot to do with your body feeling as if you are being poisoned. It's exact reaction to you being kind of food poisoning or something. You start feeling nausea. And that part has a lot to do with the fidelity not matching the real world.
And what's the fidelity? How many polygons you're using, or is
the fidelity? It will be more about the resolution, like 16K at like like 90 frames or 120 frames per second, where as long as the mind is not able to detect that you are being kind of gamed, if it is not able to distinguish, the real world and the virtual world, you're not going to feel that fatigue and that will go with what we're talking about.
Okay. Yeah. Great. Thanks. So why don't you have a seat, and DJ will ask you to give your comments, and we'll all have a discussion.
Can I ask a question?
Let's put it off until after the next set of comments. Sure. Thank you.
Thank you, Richard. Thank you, Dijam. Pleasure to be here. I used to. When I was a research engineer back at Bosch, I used to come here often to attend similar talks, so I'm actually quite chuffed to be here. All right, so brief introduction, Charter. I promise I'll try to make it short. Charter is a large cable mass media company. We go in our footprints by the name of Spectrum. And so we have about 28 million customers across 41 states in the US. And we have 98,000 employees. So some of the key points I want to hit on today. So taking a slightly different point of view, not contrarian, I'd say, but slightly different point of view than Dijam, is I want to introduce immersive as a form of entertainment, potentially. I want to hit upon the fact that there are some technical challenges, and Dijam touched on most of them. The cost of compute does need to be resolved. We can help. Service providers can help. It is also a hard problem, but it can be solved. And finally, we think our equation, our simple math equation, is bandwidth, low latency, and compute should give us superior experiences. Okay, so introducing immersive just as an extension of video. You got 2D streaming video today. There is no interactivity. All the content is preloaded, a priori. Bandwidth, with HD, even 4K, 15 to 25 megabits per second. Latency, yes, it does. If you have too much latency and too much error on the network, then obviously you'll see some artifacts. But generally, very tolerant to latency. It doesn't create the whole motion to photon experience loop. So far more tolerant. And special compute at the client display, no. We all use a hardware decoder that's in our phones or anywhere else for that matter, right? Cloud gaming. So this is basically where the content starts getting rendered on the fly. So you've got basically all your game controller input, you're mashing your controller, it's all going up in the cloud, it's rendering frames and it's bringing them back down. And that loop needs to happen at a rate at which you don't perceive the lag. So, there are many, many articles written about the subject. We're going with 50 milliseconds latency. You might find another place that says 80 millisecond latency. You might find another place that says 30 millisecond latency, right? So, but we think based on some of the field trials that we've run, 50 milliseconds latency is a pretty good estimate of the round trip loop, right? And then of course there's compute involved. There's an interesting statistic that says that the content keeps outpacing the devices, and so developers have these unique challenges. Either they can develop to all the devices and basically deliver cartoonish content, or they can develop really bespoke content, but then it's only available on a full-fledged PC with a Vive Pro HMD, for example, or an Oculus Rift. And then last but not the least, we do actually believe in this feature. So I'm going to go back and add my 2 cents to one of the things that was discussed towards the end here between you, Richard, and Dijam. There's, of course, fatigue. There's, of course, the lack of retinal grade resolution. But one of the things that has been said about AR and VR is it can be an isolating experience, especially when you look at it as a form of entertainment. Because when you like to be entertained, you sometimes want to be with friends. Right? So you can argue that, yes, now I can do this in my virtual living room with other friends who are far away. So in that sense, it's not isolating. But then with regards to your own family, it might feel really weird. Right? So again, motion to photon latency kicks in. Things like light fields sometimes are not about latency at all. They're about pure bandwidth, trying to render like 50, 100 different perspectives all at the same time, so that whichever perspective you take into looking into the light field, you without going through the motion to photon latency loop, you get your image, your view. Some challenges related to virtual reality and augmented reality as we see it. I think Dijam has been through most of this. High cost of PCs to deliver what I would call premium experiences. You've got the download to go watch a 360 video kind of stuff. But I think people who get introduced to VR that way, do not really enjoy it, right? So then the second thing is, all this fragmented content and, the battles that go on in the market. Augmented reality, once again, I think Dijam pointed to both of these, and the high price of HMDs. So this is what I would call sort of the virtuous circle. So what is the problem today? As we touched upon earlier, is this price point, right? You got to buy a $2,000 computer, then you got to buy a $400. I'd have to say $400 now today with the Rift S. So you're looking at a fully loaded price of $2,500 to access a premium experience, or thereabouts, maybe $2,000. Maybe you get a good deal, right? So the challenges of users are: should I invest in this? I've got limited content. I've got a high price of HMD. At the same time, the developers are like, what's the point of making VR content? What's the point of making ARVR content? Because I can't monetize it, right? And then the HMD guys are like, I really need scale so that I can bring down the price points of my HMDs. So what needs to happen in this market is that the virtuous growth cycle needs to be stimulated. How can network service providers help? We think that if we embed compute in the network, we may be able to jumpstart this virtuous cycle. Once you're able to take some of that compute out, then you can deliver those premium experiences on low power HMDs that don't heat up, that have good form factors. That essentially leads to more people buying. Developers earn more money. All the tools improve. Content gets less fragmented as the industry matures. So a long time back, think I stole this statement from a Sun Microsystems John Gage. The network is the computer, and I'm adding my own twist to it because the network will be the computer again. So to the left is basically, proven artifacts that GPUs can be migrated to the cloud to deliver cloud gaming. I mean, you've all heard of Stadia. Of course, some of the early reviews have been a little rough, but we invested in 2018 in a company called Blade Shadow, which does something similar but different in many ways. But essentially, it's a cloud gaming solution, and it has been proven to essentially work under certain constraints. And it is indeed a proximity-based solution. So that's really one of the constraints. You got to think about some kind of an edge. That edge is not your local last mile. That edge can be far away. So all of this followed by AR, VR, and some of the streaming content as it develops. Service providers may choose to find the business case profitable to start moving compute from national data centers to regional data centers, and then back down to the edge data centers. And then last but not the least, as you start seeing more and more light field displays, clients that demand more and more from the network, then bandwidth, latency, and all of those things evolve, along with the compute. So this is one of our ecosystem building activities. This year, earlier, we founded the IDEA, or the Immersive Digital Experiences Alliance. I highly encourage you guys to go check it out at immersivealliance.org. What are we doing? We're trying to create a royalty-free technical specifications around the conveyance of immersive media. And we generally do education seminars, and we basically curate new ideas. And what I'm specifically interested in, the work group that I lead is the network architecture work group. And we have a huge spectrum of content, right? You've got essentially ray tracing. You got to run this on multiple GPUs for X hours to render out cinematic content. And then there's the interactive content, which is like, can I virtualize my GPU? Can I slice it? And can I use it? So there's a huge spectrum. And we're looking at how the network could potentially support all of these applications, perhaps in real time. We don't know whether we can do all of it in real time, such as ray tracing and physically based rendering engines. But we're doing some experiments. And so this is some early curation of ideas on what direction we're moving in, which is that essentially, in today's world, in the video world, there's an end-to-end flow that actually gets negotiated end-to-end. But what we're looking at is, can the network actively engage? Can there be a quality of experience attributes and client attributes that help describe the quality of experience attributes that can then lead to the network actually engaging storage, engaging compute, engaging its networking capabilities, so that the right quality of experience can be delivered to the right device. Okay, I love this slide. Simple. My equation, there's a delicate balance depending on the application and the quality of experience. You need to balance all of these three things. There's bandwidth, there's latency, and there's compute. So now I can finally move into edge computing more as a concluding remarks, since I started with AR and VR. So I basically took these off of this State of the Edge 2018 report. I highly encourage you to read it. Essentially, all this is a set of use cases. You've got autonomous vehicles, which is going to be, ultra sensitive to latency and jitter. There's edge content delivery, which may be just about better video delivery. There's video surveillance, where there's a huge deluge of upstream data, video data. There's AI and machine learning. I already talked about gaming and AR, VR. And then Yes. Yes.
What is the scale? What's on the left side and what's on the right side?
So, first of all, do not take the color coding to mean good, bad, or medium.
Okay.
So that's my so red doesn't mean bad. All of this is so there is no scale,
Okay.
right? Because none of these applications have actually happened, but it is someone's attempt to try and put sort of an idea of a scale without units on this. So I mean, availability can still be measured. Security, you'd have to probably come up with a serious metric to measure security at the edge.
But the point is kind of like how important it is for the success of the
Attributes,
application
yes.
type?
Yeah, exactly.
Yeah.
This is really, this is somebody else's rendition of what attributes matter. And in all of the edge use cases, perhaps, which attributes, like for example, high bandwidth and low latency, is that what's going to go on? Or is it maybe not latency sensitive, like he says, with video surveillance, not as latency sensitive? So yeah, I mean,
Okay.
I am not going to claim authorship of this. It is a rendition. Take it for what it's worth.
So on your autonomous vehicles, is that the second line near latency,
Yes.
to the left, does that imply it's not important or that it is important?
Low and high. And that's it. Red does not mean,
No,
Yeah.
latency.
yes. So latency is low. And it's,
Low to high.
yes. Low is by the definition of this guy blue, right? Whether
a
it means
system-
more resource
yeah.
constraint, it by definition still, he has called it blue.
A
Right.
system with,
Yes.
for autonomous vehicles will have high bandwidth, low
And low
latency, low jitter,
Yes.
very high availability, and
Yes.
also high security.
Yes. So I appreciate the
Okay.
thoughts on this slide. This
Yeah,
was the first
sorry.
time I was beta testing this one. Clearly, it could do with some improvement here. Anyway, so I'll come to my concluding slide, okay? So I do believe that the network edge computing has a potential to democratize AR, VR, and other immersive experiences. I'd make a slightly provocative statement here for those of you who have been following 5G, which is that low latency, high bandwidth is probably certainly is a prerequisite to reap the benefits of edge computing. However, edge computing is actually agnostic of any network technology. So, if 5G offers you, in future, if LTE offers you 25 to 30 milliseconds latency on the access network, today DOCSIS 3.1 will offer you something like 10 milliseconds. Then 5G will make it 2 to 5 milliseconds. And then, we have a path to 1 millisecond latency over fiber as well. So there's going to be some industry competition that is going to be beneficial to the consumer to drive latencies down. And then last but not the least, this was a very interesting report that came out. Again, I encourage you guys to take a look. Is Chetan Sharma claims that the edge internet economy in about a decade from now will kind of achieve the same scale and size as the cloud economy of today or the mobile economy. So yeah, with that, I will conclude here.
Those are very large numbers.
Very large numbers.
DJ,
yes.
thanks. Dijam, let's go join DJ up on stage. And you had a question that I made you put off, so why don't you go ahead and ask? I'll let you go first, even before me.
In terms of computation, how do you explain the computation between the local device and the edge and the cloud?
So the question is, how do we decide that
Yeah.
where do we put what compute?
That's right.
Yeah.
You put the rendering in cloud or local device or on the edge.
Sure.
How do you decide this?
Yeah. So we have this ability. So if you take any of the immersive experiences, there are different tasks you can identify. One of the things I was talking about was like the global lighting. Whenever you see a VR experience, so there is a lighting, shadow. There are many aspects, many tasks which are there, and within that, the aspects which is more dynamic, like which requires an immediate, what I say, a real-time movement, anything that involves around that, it has a low latency budget. So you need to do it closer to you. So, but like a global lighting has almost like a 200 millisecond kind of a budget. So I can have the global lighting done on even a compute node which is farther, which in this case could be a cloud if the cloud is available to me within a 200 millisecond. On the device side, because the whole thing, we do use the device as well. As I was pointing out that we know that the wireless network is finicky. And many of the actions that we are taking is based on our prediction algorithm. And at the end of the day, the prediction is a probability, right? It may not, some of the prediction may not be correct, and then we have to reconstruct the whole scene using the device itself with the past data. There's some caching that we have done. We know the past state of and what is the position or the gauge of the person who is kind of using it. We can actually recreate the whole thing on the device itself. So that's how we can kind of do that and identify the task and kind of run it at different nodes.
Okay, before we get into other audience questions, can I ask you real quick, how far along is Grid Raster? How much money have you raised?
Sure. Yeah, so we actually closed a round very, very recently, a 2.4 million round. So we have raised close to 3.2 million right now altogether. And hopefully, with all the engagements that we have and pretty confident that we'll have the commercial things done, I think the coming year, 2020, we should have raised our next round.
So is your model going to be licensing the platform? That's the business?
Yes, that would be the end goal, where we could be it would be an annual licensing kind of a model, where we license our technology, and on top of it, anybody wants to run any use cases they want to do.
So you're going to make it open source?
It's too early.
Okay, good answer. I'm putting off a lot of people. I saw 3 hands over here. Why don't you go first, and then you, okay? Go ahead, you're first.
I have 2 questions. The first one, I think you mentioned you need below 20 milliseconds photon, and I agree. But then the round trip delay adds, and it's 80. So how would that work? And then so that's just for the there is also multiprocessing that has to be done when you have to move the heads and all that. So I'm curious. And then the other question is, you suggested to split the compute from the network to the device, but what standard is being used? For operators, I'm not aware of a standard. I know that, for example, Nokia and Ericsson and Huawei are disagreeing on standardization. So just wondering if it's
real
just
quick.
Theory or...
So standardization of edge computing architectures, right? That's what you're talking about. So
yeah, and the first one was like, is it even practical because of the real
dividing up the compute. Yeah.
Why? So the way we do it is, just think of it, the game logic kind of runs on the server side. Just to kind of give a quick answer to that. What we do, as I said, there's a lot of prediction-based. So my network, as I showed, like even if it's like 40 millisecond away, what essentially I'm trying to do here is, I'm running my game logic on the cloud and rendering the views and everything 40 to 50 millisecond before even the user kind of does anything around that. And this is what the prediction part of it is. And if I have kind of put the data already onto the device, or cached it onto the device, now based on the user position or any specific interaction, I don't have to go back to the cloud to kind of show that, because I've already done that. I've already put it onto the device. Only places where my prediction is not able to, my prediction is not right, and the user actually makes a movement which I didn't kind of predict it correctly. In that case, I have to regenerate everything on the device. That's at the broad level what we are kind of doing. And by using that, now how far that on the network I can put the compute has a lot to do with how much bandwidth that is available. For me, it could be a case that I kind of generate everything and put it onto the device, the storage that is required on the device. So there is a trade-off that we are doing on that. But today, the best mark that we have reached is like 40 at a 60 frames per second, 2K kind of a resolution. We can actually, even if it's 40 millisecond away, we can reduce the perceptible delay to sub 20 millisecond. And it has a lot to do with the prediction algorithms that we are running.
So to what extent is standardization going to be essential, or is it going to be different from application to application?
I think DJ.
That's a DJ question.
So I wouldn't call anything standardization right now. I think we are all in an ecosystem building phase. And there are some, essentially, I mean, the way at least my opinion about standards is when, something is so mature that, it's not a key part of the value chain, and now you need to move to the next level of things, that's when you come up with some level of standardization. And I feel like this area is very, very new. That said, there are some good ecosystem and specifications, for example, that have come out of OpenXR, which is more about trying to make sure that this fragmentation that is occurring between compatibility of headset and content doesn't occur in future. There's a new virtual link. If any of you have tried VR to laptops, you've got all these unwieldy cables. So there's a new virtual link standard which will help to standardize the hardware interface there. And then in the idea group, we're looking at what does a distribution format, which is 3D media native, look like. So we just actually put out an ITMF, Immersive Technologies Media Format out there, which basically specs a scene graph. And there are versions of scene graphs out there, like GLT, OpenGL, GLTF, which is a transmission format, so on and so forth. So we just found some of the existing formats somewhat inadequate for highly photorealistic rendering. So we did something like that.
I need to ask a follow-up question before we go on with your questions. So neither one of you mentioned an MEC, which either is mobile edge controller or multi-access edge controller.
Yes.
And maybe this is also a DJ question. Are those something that the network is likely to own, and it may be located in a base station? Are you thinking of, because you'll also have a bunch of truly mobile ones like inside self-driving cars or connected cars.
Right. So I mean, mobile edge computing or multi-access edge computing, to be more accurate, essentially is about, assuming you have an edge, it is about contextual information available to you all the time, right? The problem with mobile edge compute or multi-access edge compute is it doesn't really address immersive. Immersive mech is really addressed by guys like Grid Raster and some of the work we are also doing in partnership. So I'd have to say that existing mech is highly inadequate to really address ARVR.
Okay, so that's another kind of initiative that has to be done. This is something work to be done.
Okay, so I would also say this, that there are things that need to run out of Etsy because they link to how the guys are going to make chipsets and so on and so forth. I don't believe it has been determined that an immersive mech necessarily needs to come out of Etsy.
Okay.
So,
okay.
until somebody makes that determination.
So I'm seeing lots of hands. Why don't you go next, and then you go, please. Okay.
So VR, it requires headsets, and AR can be tablets, smartphone, car windshield, or headsets. The problem with VR right now is the headsets. I have tried $3,000 HoloLens 1 and 2, and the is that Magic Leaps?
Magic Leap 1. Yeah.
Which is kind of light, but I could only wear two $300 Oculus Quest. I could only watch no more than 10 minutes because, just like you say, there's fatigue, and also the weight on my the pressure.
The nose bridge, yes,
Um,
literally.
I think that's the reason it hasn't caught up in the mass adoption and market.
Yes.
AR maybe, because Apple maybe in 2 years gonna release their AR glasses that is connected to smartphone, not independent
Yeah.
eyeglasses. How many years do you think that these will become a mass market, mass adoptions, that we as developers can make money?
So Dijam, you had mentioned that enterprise is going to be first,
Yeah.
right?
So, I mean, that's something we kind of also juggle, like think about every day, right? Just how do you monetize? Because end of the day, the platform, unless it is used by somebody, it's going to, we are not going to make money, right? What we are seeing is that the consumer story has, I think, there are a lot of variables which needs to be kind of fall in place. Like as you said, first the device, then there's a price point, then people getting comfortable, then then the whole content. The good thing with, and the reason we kind of moved from the consumer to the enterprise is precisely this reason, that in enterprises, it's more value driven, right? So for example, I'll take the case of in aerospace. Let's suppose there is an airplane, something has gone wrong, and it's actually stranded in one of the hangars somewhere, let's suppose in India. And let's suppose it was an Airbus airplane which was kind of there. Now, what is happening using AR? Earlier, what used to happen, the expert would travel all the way from France to India, repair it, and then come back. The cost of travel is insignificant. What is significant is the amount of time that the plane was kind of landing. That's not flying, okay? And that amount could run into hundreds of K, okay? For them, using a HoloLens, which even if it takes like 3K, 5K, it's still, the value they will get out of it is like humongous, okay?
But I still don't see conference rooms where people are wearing headsets, VR
So,
headsets
okay,
for.
we're on the early side of this.
Yeah.
What kind
Yeah.
of a time frame are you seeing for adopting
trend?
AR in industrial settings?
No, on the industrial setting, what I'm saying is they're already beginning to deploy.
Okay.
So there you would, there is one of the customer, obviously, I'm not able to reveal the name, they're actually buying HoloLens in thousands now.
For training, right? Mostly.
Not only training, for even the manufacturing processes. For hands-on, somebody doing, and you get the overlay of all the models or the steps, instructions that you need to do. Buying HoloLens in like thousands. When I'm talking thousands, it's multiple thousands. Now that's what they're beginning to use it. That's the scale that we're looking at.
So on the one side, we're already seeing movement. There's an awful lot more movement we'll have yet to see. DJ, what do you think about the immersive kind of side, immersive
Yes.
experiences?
Yes, so, I mean, if you look at penetration
Timeline.
of at least consumer stuff today, I mean, depending on which report you look at, it's somewhere between 5 and 10%, right? Or 5 and 11, or something like that, right?
Sure, I'll just excuse me.
If you look at
Okay,
what
sure.
analysts predict, they say there will be some level of an inflection point in 2021, right? So, if I discount out the eagerness of analysts.
Sure. I noticed that AR/VR, the security requirements are like in the middle. Now, if you're doing industrial, like you're looking at a Boeing engine being mounted in the wrong place or something like that, or you're doing surgery, that's where it's going to start, okay? Right now, there is absolutely no security or very minimum security in most of these devices. Given the complexity, they should be more secure. Why did you put it in the middle? Because I would say you would move it much further, because a hack on these devices is going to have much more severe.
Absolutely, absolutely. In fact, if you talk to Dijam, he'll be like, on-premise edge is the best edge, right? I mean, so anyway, I'll just give you some insight on the guy who wrote that. These guys who actually put that report together, these are some of the guys who are building some of these micro data centers where they want to provide peering points on the internet at the local edge, because they believe that they want to build the next internet, the ultra low latency internet. So their perspective is a little more consumer.
DJ, while you're on that, are you looking at, say, the development of these kinds of architectures in other places besides the U.S. too? Because I understand that there's some, 2 to 5 rack micro data centers being constructed in some of the smart cities in China.
Look, I mean, I've heard great things about China. I've heard great things about SK Telecom in Korea, right? And so some of these stories are actually, excellent use cases of how the world should do their development. That said, I mean, the U.S. is a very large swath, right? I mean, you got to run a backbone across the U.S. I mean, it's crazy. It's a huge landmass as you run fiber across of it. And then you take that core and backbone, and then you move into market data centers, and then you move into head ends, or what Dijam called central offices for telcos, and then you're serving a few hundred homes on the end. So there's a lot today that goes on building a network like that. But I think some of the other insights I'd offer is in places like Asia, I think this is kind of relevant to AR and VR, is there's a lot of location-based entertainment, far greater than the US, that is actually also cropping up. So that's a very interesting trend. I mean, in places where I'd say cost of compute may still be higher, you're actually finding, some of these successful people, if you look at Servio's business model, for example, it's like, they just set up, a reseller of Servio's content would basically set up 8-foot by 8-foot bays. And the same experience that a US consumer would pay $3,000 for, they would get it in Asia in a location for, I don't know, for pennies on the dollar, I would imagine. So there's a lot of that going on in Asia. In the US, on the other hand, these location-based experiences are very jazzed up.
Okay. You got your mic?
And to some extent, there's a large segment of the population that has actually not experienced VR right in the US at all, because there's nothing in between. There isn't that, 8-foot by 8-foot bay. But I highly do encourage you guys, if anybody's not been to Dave & Buster's, to check out some of their $5 experiences. I think they were pretty good.
Okay, thank you. Go ahead.
I wanted to get that, and are you okay, Dijam?
Yeah, I'm fine. I don't know, from the morning there's something giggling, so.
So back to your business model that you envisioned, what you described somehow sounded more like the Ford T1 option, where you are looking at the general consumer versus working with partners like Besto and Autodesk to partner up and actually integrate your solution so that from a user's perspective, this is absolutely seamless.
It's a question for me, right?
Yeah.
Yeah. Yes. So the way we are looking at, yes, there will be channel partners. That will always be there, and Autodesk or Dassault systems, they would be like excellent from our angle. What for us at this stage, what it goes beyond is whatever we're building, it needs to be used. Okay, and that's where I think we will be able to evolve the value in the product. So today, that's the reason our initial customers, that 5 or 6 of them that we are currently working, is all like directly working with them. Okay, and with that we are learning, like somebody is using PDC Creo, somebody is using the Autodesk or the CATIA models. Even in the same organization, people have CATIA for different purposes. Different group use different purposes. So those are the things actually we're learning, which is more on the integration side of it, the productization side of the things. Yes, once we kind of trash that out, it would be excellent for me to kind of take this solution to an Autodesk. Like, okay, I can enable you this with all your different all your different customers who kind of require it. Like we are also a part of the Siemens the Frontier program. They have which kind of pretty well kind of overlaps with us in terms of the focus. They have a pretty big presence in the automotive and aerospace. I think 70% of the revenue come from that. So that's something that we are already kind of beginning to start working with.
So a follow-up question, and I will stand corrected. Did you offer Stanford an opportunity to use your platform as a test bed for research?
Not yet. But we did kind of apply at some stage to the what is that, statics forum, but I think it was too preliminary for us. That's all.
We're always here.
Sure.
To collaborate and
Yeah.
do together what neither of us can do by ourselves.
Sure. Absolutely.
Thanks. Other questions? Go ahead.
Yes, so did I hear you say the Valus network?
Sorry.
The Valus network, or maybe I misunderstood it. So I thought you were talking about something like you used the phrase Valus network?
Wireless.
Wireless.
Yeah, yeah.
Oh, okay, I thought there was
Okay.
a little player here
Yeah.
called Valus that I'd never heard of.
Yeah.
Yeah, okay.
Wireless,
Okay, good. Next question.
So are you looking at the impact that GPUs and FPGAs might have on, especially when you think about streaming data, you know, Kafka and some of those kinds of things?
I think, yes, any development on the GPU, on the FPGA, that part of it only helps us, you know.
Especially from an edge, you know, stuff.
You're saying on the device?
Yeah,
On the device.
not necessarily in goggles or anything like that, but certainly from an edge device.
By which it could be an edge server. Could be one hop away from the end device,
Well,
by your definition.
Yes.
you know, edge takes on a lot of different definitions in terms of, you know, what's on-prem these days. On-prem could be, you know, right at, you know, the point of where it's generated.
So I just add, all of yesterday I was in a conference, which was the Edge AI Summit. There, the edge is always the device. It's the inferring, that is what they call the edge, the
Well,
inference device.
so not necessarily the device that's generating the data, but there has to be a collection point
Right.
where certain decisions have to be made in terms of how data gets managed, how it gets distributed,
Yes.
you know, those types of decisions.
Can I kind of throw my own opinion into this?
Sure.
So you're going to have all sorts of different architectures.
Right.
You may have a factory, if you've got workers going around with glasses, they're not gonna have much on the glasses in terms of a system board. And so it makes much more sense to have something on the floor of the factory that's kind of doing most of the processing right there at the factory. In a self-driving car, it's gotta pretty much be in the car.
Well, it's a data center on wheels.
And, yeah, I saw that from Volvo a few weeks ago.
It has 1,500 processors in it.
Yeah, but in any case, you're gonna see different things. It's not that one is right, it's getting the right fit for the right business. And that's gonna be where the killer, you know,
Yeah.
kind of
That's why I like
success is gonna be.
Dijam's framing the hierarchy of compute, right? So if you have compute everywhere, then based on the quality of experience that's needed, you have to make some dynamic
And then from an
decisions.
architectural
Yeah.
standpoint, you get all kinds of cloud native kind of things, you know, starting to play into that as well.
I also like your point about Edge being agnostic of the network, which means that Edge can go on and develop. You don't have to wait for 5G.
Absolutely.
And I think that this too, in some ways, Edge optimizes the network infrastructure that you have. But it must be kind of scary for a telecom company to think about the sort of possible capital expenditures that might be involved in having the compute infrastructure to support edge computing.
And that's exactly right? So you've got, I mean, if you look at it from a telecom company's point of view, they first have to get all the connectivity in low, mid, and high band, and then they have to get the compute in. And I think for any operator which has a capital-intensive business, this is going to be a challenge. I think we're thinking about it.
Software defined and
Yes.
virtualization is going to have a huge impact in terms of all the, configured, and, how those services will configured.
Exactly. I mean, all of so I'll once again go back to sort of the hierarchy of compute analogy, but I mean, the way we look at the network is, if there are access to your point, virtualization and software-defined network, if there are any of those latency critical functions that are right around, PHY, MAC, or, radio selection, all of those will have to sit right at the edge of the access network, which, for a telco is a tower, right? For us is a different piece of equipment. But
If I can
yes.
also kind of interrupt and put a plug in, the videos of most of the previous sessions in this series are already viewable online. You can see them on our website, asia.stanford.edu, and they're free, total access. The third session in our program was from Intel about chip acceleration. And so, that has been discussed in this series already.
Right.
From an
Yeah.
FPGA perspective, or their EP?
Well, actually, you've got FPGA, you've got GPU, and increasingly you have ASICs. Because if you have large numbers of devices, then it becomes cost effective to design a mission-specific chip for that specific device. And you'll always be able to reduce wiring and reduce the size of the chip and get faster throughput and lower power. So that's really a huge thing that the chip industry is just delighted about right now.
Yes, yes. I'd mention also that, for us, we talk in terms of converged networks now. So, it really depends, depending on where you're at. It could be wired, it could be wireless, it could be a small cell, it could be Wi-Fi, So, it's really about, where you're at and what's your best link.
What are the things that you're most worried might prevent kind of what could happen in edge computing? What do you think are the sort of big dangers on the horizon that could mess up this whole picture?
Dijam, you want to go first?
Also known as, what do you worry about when you get up in the morning?
You're making the capital expense, so you would be better placed.
Well, I mean, I think, the edge computing industry has barely started, and so we have not even hit what I call the hype cycle just yet. We're about getting there, right? So today, I don't think that we have a trough of disillusionment quite happening just yet. So it's about getting your decisions right. It's about getting your business cases right. And I'm pretty sure, though, in the future that there would be lots of things that would keep us up at night. But what I would like to see is mass adoption of immersive, right? In my world.
For me, the couple of things on the edge computing, so as I was saying, the reason that we went after use cases based on value rather than the volume was because for the volume to happen, there are many other aspects. Even from a computing standpoint, the GPUs are still pretty expensive. GPUs are still very expensive. If you're looking to build the kind of the volume that you're looking at those price points also has to kind of come down. Yes. And if they do not happen, the kind of money that will be required to kind of put out that kind of infrastructure is going to be quite challenging. So I definitely see the price point of GPU coming down, and that's going to happen considering which some of the information insights that we have and the developments that is happening in even like all the biggies are kind of coming in there. So that's definitely, the more you hear about it, the less risky you start looking, and that's how we just have to kind of navigate.
Okay, great. I'm afraid we kind of have run out of time. We've got some refreshments outside. Please plan on continuing our conversations in a more informal setting. For now, if you would, please join me in thanking Dijam and DJ.
Thank you very much.
Thank you.